Good evening, everyone, and welcome. Good afternoon or evening, whatever it is. Welcome to this lecture. We are dealing with electrostatics, and in the past class, we had done with some questions based on the force between two charged particles. Yes or no? We'll continue with those with such questions on electric force and questions on what should I say? Electric field. Remember, after electric force, we'll move on to electric field. And we will solve questions based on that. We had done one question. I think we should do one or two more questions based on this. One or two more questions based on this, on the type that are supposed to come in your where is this in your NEET exam, and this is the question that I find. Again, most of the questions are taken from your previous exam, and the same questions you might find them in your exams only. This is the first one. Two charges, 1 microcoulomb and 5 microcoulomb, are separated by a certain distance. What will be the ratio of forces acting on these two? So they will exert forces on each other. What will be the forces what will be the forces acting on each other? And the answer is remember, these are the type of questions that are coming that are going to come in the exam, so I'm only concentrating and doing those questions. Remember to mark these questions and remember them. Yes, bacha. What is the answer for this one? What will be the ratio of forces acting on these two? And the answer is
So 1:1.
1:1. Equal and opposite forces, action and reaction. Remember that. Don't forget simple things. These are the questions that are going to come. Can you move on to the next one? Anyone understands this? Yes or no?
Yes, sir.
This is the next one. I have seen such question come many times in JEE as well as NEET. This is the next question. Two charges of 40 microcoulomb and 20 microcoulomb are placed at a certain distance apart. They are touched and are kept at the same distance. What is the ratio of initial and the final force? I'll give you 1 minute to do this. What is the ratio of initial and the final force? So this will make you understand what happens when you touch two spheres or two charges. What will happen when you touch them? Anyone? I'll give you 2 minutes, don't worry. Do we have an answer, bacha?
Sir, 8:1.
Are you asking me or are you telling me 8:1?
Telling, sir.
Telling, sir. That is correct, sir. The answer is 8:1. Well done. How did you get the answer 8:1? Now remember, they are placed at the same distance. Now, how are we supposed to solve this question? Let me first name this question as question number 2, and then let me write the solution. Now, this force acting on these two is equal to K times Q1, Q2 divided by R square. Now, remember, oops, you can't see this probably. Okay, K times Q1, Q2 divided by R square. Now, here, they are kept in the same medium, K is same. They are kept at the same distance, R is same, right? So, I can easily say that this force will be proportional to the magnitude of their charges. Yes or no?
Yes, sir.
So in first case, F1 becomes proportional to 40 multiplied by 20. Remember, I'm talking about the magnitude, sign doesn't matter. So F1 will be equal to 40 multiplied by 20. Now what happens when you touch them? When you touch them, and we will see this in much detail in the chapter on capacitance or after that, they come to the same potential. And if the charges are same, if the shape and size are same, they will have the same, the total charge will get redistributed. The total charge should remain same. So if I look at the total charge of the system, what was the total charge of the system? 40 plus minus 20. So the total charge of the system was 20 microcoulomb. Do we understand this? Yes or no?
Yes, sir.
Now this total charge of the system, and I'm assuming that both these bodies are same, this it will get divided equally. So one of them will have 10 and the other one will also have 10. Do we understand this?
Yes, sir.
So in the second case, the charge on them will become 10 into 10 each. So the force will be proportional to 10 into 10. How do you find out the ratio? It is now very simple. 80 into 10 divided by 10 into 10. And the ratio turns out as 8:1. Remember, such questions are in fashion these days, and you can expect questions on this. Sometimes what happens is the spheres are not given as equal, they're unequal, but you don't expect such questions in NEET. Such questions will only happen in JEE. Do we understand this?
Yes, sir.
Now, this is one of the very pet questions that has come in many exams in many times, and I won't require you to solve it. I would just require you to remember this and remember the answer for this one. So the question goes like this: you have a charge Q, and you divide it in two parts, Q1 and Q2, and you place it at a distance R. You are supposed to find out when will maximum repulsion occur. And what ratio should you divide those charges so that the repulsion or the force between them is maximum. Remember, this question has come many times. So remember, the force will be maximum when both the charges are equal. So the correct option is option D. So remember this. If you divide a charge into two parts and you want the force between those two charges to be maximum, your charges should be equal. Remember this, keep it as a note, keep it with you. Okay? Shall we move on to the next question?
Yes, sir.
This is the next question. These are the type of question that can come if they come. The force between two charges 0.06 meters apart is 5 Newton. If each charge is moved towards each other by 0.01 meter, what will be the new force? I'll give you 2 minutes to solve this. उसको यहाँ लग गई। हाँ any answers बच्चा? Shall I solve it, beta? So the charges are same. The only thing that has changed is the distance. Yes or no? So remember, force is equal to K Q1 Q2 by R square. Here the charges are same. So K is same. So I can say that this force is proportional to 1 by r square. In first case, F1 was proportional to 1 by 0.06 square. In second case, F2, both of them has been brought closer by 0.01. So the distance has become 0.04. Yes or no? The distance has become 0.04. So the next force, which is going to come on your screens now, so the next force is proportional to 1 by 0.04 square. Do we understand this? Yes or no?
Yes, sir.
So I can find out the ratio then. F1 by F2 will be equal to 0.04 divided by 0.06 whole square. This will be coming as 2 by 3 whole square, 4 by 9. F1 by F2 is 4 by 9. You already know the value of F1. You can find out the value of F2. I think F2 is coming as 11.25 newtons. Are we getting the same answer? Yes or no?
Yes, sir.
Okay, I'll give you 1 minute to note this down. Then you can move on to the next question. Let me know once you are done. Can you move on to the next question?
Yes, sir.
So here is the next question. Two charges equal in magnitude but opposite in polarity are placed at a distance, certain distance apart. Force between them is F. 75% of one charge is transferred to the other. What is the force between them now? Give you 2 minutes to solve this.
Sir?
Yes, bacha.
Option B, sir.
Option B, 9 by 16. It is F by 16, not 9 by 16. F by 16. I hope you have read the question carefully. Two charges equal in magnitude but opposite in polarity. Like this. This is the original configuration. I hope you understand it. Yes or no?
Yes, sir.
75% of charge of one is transferred to the other. If I say it is transferred from the positive charge to the negative charge, what will be the final configuration like? It would be like this. 75% matlab 3/4. 3/4 of charge is taken from plus Q. So what is left with plus Q? Q by 4. Now this plus 3Q by 4 is given to minus Q. So what is the charge on minus Q? The charge on minus Q becomes minus Q by 4 and the charge on plus Q becomes plus Q by 4. Do we understand this?
Yes, sir.
Now can you give me the answer?
F by 16, sir.
F by 16. Yes, it will be F by 16 because the initial force, as you can see, the initial force will be KQ square by R square. And if you look at the final force, both the charges have become 1/4. So the force will definitely become 1 by 16. No questions asked, no answers given. And I hope we understand this. Yes or no? No, yes.
Yes, sir.
Everyone understands this? I'll give you 2 minutes to note down the question. These are the type of question beta that you can expect in the examination hall. So I'm just doing very, very selective questions. And I'm not doing any question which I don't think will come. Have you noted this down?
Done, sir.
Then this is one question which you must remember and you must know so that I cover even the difficult ones if a difficult one comes. This is probably the most difficult one that can come in this category. Let me name it. Question number 5. 3 equal charges, each Q are placed at the corners of an equilateral triangle of side A. What will be the force on any of the charge? So any of the charge, on any 3 of the charge, forces are going to be same in magnitude. To find the force on any one of the charge, I'll give you 2 minutes to do this.
Sir,
Yes, bacha.
option D, sir.
Option?
D.
Option D, sir. Let me look at the option D. Where is my book? Option D. That is correct. How did you get option D? That is correct. Have you done this question before?
Yes, sir.
Okay, so you remember it or you have done it again?
We remembered it, sir.
Okay, it's good that you remember it because sometimes your remembrance might help you a lot. So this is the diagram. It looks like this. Now remember what is the quickest way of doing it, and you must know the quickest way. All the charges are same, so I'm going to find the force because of these two charges on this green charge. All the forces are same. Whatever force the pink charge will apply on the green charge, it is going to be same. This fb is the force applied by the charge b. Do we understand this? And this
Yes, sir.
fc is the force applied by the charge c. Both are same, and these two forces will come at an angle, and that angle is going to be 60 degrees. So you can find the net force with the vector addition. It will be equal to under root of a square f square plus f square. Both forces are same. Do we understand this? Plus 2
Yes,
times f into cos of 60 degrees. Do we understand this? The value of this f will be the force between any two pairs, and that will be equal to kq square by r square, or a square, the length of the side, whatever is given. So this f net will come as, I think, root 3 times of f. Yes or no?
yes, sir.
Just remember that it is going to come as root 3 times of f, and you don't have to remember anything else. Do we understand this?
Yes, sir.
We'll do one more question because I think that even this question can come. Have we noted it down, everyone?
Done, sir.
Then we are going to do one more question on this. Now, this is a question where 5 charges are placed on the uh, vertices of a regular hexagon. Now, this question can be asked in different ways, but this is the most common way in which it is asked. Normally, the diagram is not given, but in your case, if they ask you this question, probably the diagram would be given. So let me show you the diagram also. The diagram is like this, and then they ask you what is the force on the central charge. You can easily do it.
Sir, option C. Sir,
What is the answer?
C.
Answer is C, 0. No, answer is not C, 0. The answer would be 0 if you place one more here. But
Option A, sir.
if the arrangement is like this, if I place all the 6 vertices, I place, then the answer is 0. Do we understand this, beta? It is not here. Now, how you are going to get the answer? See, you look at the symmetry of the diagram. Whatever force this charge will create on the central charge, this charge will negate. They will cancel each other out. Yes or no?
Sir,
Whatever
Yes,
force
sir.
this green charge will create, this green charge will cancel out that force. So what remains is this charge. You just have to find the force on this charge. And remember, for a hexagon, all the sides are equal. Everything has got a side length of L. So the force on the charge that is remaining, because of that charge that is remaining, is kq square by L square. So your answer
option
is,
A.
do we understand this? Remember such questions. We understand this, everyone.
Yes, sir.
Yes, sir.
Okay. So these are the questions that you must remember and do. Everyone understands everything?
Yes, sir.
Yes, sir.
That takes us to the next heading, and the next heading is known as electric field. Next heading is known as electric field. What do you mean by an electric field? Yes. What do you mean by an electric field? Anyone? We are also in a space where we experience one type of field. It is not electric field, but it is similar to electric field in some senses. What field are we experiencing where we are sitting? What field are we experiencing? Gravity. Yes, we are experiencing a Viram gravitational field. But here we are not talking about that gravitational field. We are talking about electric field, which is in some ways, many ways, similar to a gravitational field. But what is an electric field? How do you understand an electric field? How do you define an electric field? Yes. So electric field is a region in space. It is a region in space where what happens? Where a charge experiences electrostatic force. So if you have a charge, this is a charge, and if this charge I keep here and it experiences electrostatic force, that means it is placed in a region of electric field. That is what we understand by electric field. Do we understand this, or this has gone above our saying bye bye?
Yes, sir.
Similarly, gravitational field is a region in space where a body with mass m experiences gravitational force. Here, the charge will experience electrostatic force because of its charge. If a mass experiences force, if a body experiences force because of its mass, it is gravitational field. If a body experiences force because of its charge, it is electrostatic or electric field. Do we understand this? Yes or no? No, yes.
Yes, sir.
Now, to understand this electric field, we have to find out how big or how strong it is. So we use this term electric field intensity or the intensity of electric field. Sometimes when someone says electric field, he means the same thing, electric field intensity or electric field. You can define this by letter E. Electric field or electric field intensity or the magnitude of electric field is denoted by letter E, E vector. What do you mean by electric field intensity? It tells us how strong the electric field is. How will you find out the value of electric field? This is the value of electric field. How will you find out the value of electric field or the electric field intensity at any point in space? So you do what? You place a very small charge. We call it the test charge. You place a very small charge. We call it the test charge. If there is electric field, this test charge will experience an electrostatic force. This test charge will experience an electrostatic force. As soon as you see that the test charge experiences the electrostatic force, this electric field will be force per unit charge. But you must write it like this in a better way. So I will write it better like this. Limit Q naught tending towards 0 F by Q naught. You want this Q naught, which is your test charge, to be very small. Why you want it to be very small? Because if this is very large or it has a large magnitude, it will create its own electric field, and then the original electric field which you want to measure will not be coming same. It will be distorted, and therefore you want this small charge to be as small as possible. Do we understand this? So
Yes,
electric
sir.
field intensity at any point in space is the force per unit charge. Do we understand this? Electric field intensity at any point is force per unit charge. Everyone understands this? Yes or no?
Yes, sir.
Force per unit charge is the electric field intensity. Now I can write this equation in a different way. How I can write this equation in a different way? This is the first way of writing this equation. The second way of writing this equation is, if you want to find out the electrostatic force on any charge, what do? You multiply the charge by electric field. So if you want to find the electrostatic force on any charge, what do? You remove that charge, you find the value of electric field at that point and multiply it by the value of charge. You will get the force on that charge. That means all the questions that we have done for electric field can be made as questions on all the questions that we have done on force can be made as question on field. For example, in this previous question, we had asked what is the force on this charge. Do you remember? We had asked what is the force on this charge. If I remove this charge from here, the question can be very easily made. What is the electric field at this point? And the answer will be same. The only difference is the value of charge will not be there. So whenever we have found out the force, see in the previous question, before that equilateral triangle wala question, we had found out the force on this charge. If I remove the force on this charge, you can find out the electric field at this point. Do we understand this? Once you get the value of electric field, you multiply it by the charge which was there, and you will get the electrostatic force. So every question where we found out the force was actually a question of electric field. So whatever questions we have done are already done. What we got to do now is to do questions which are different. Yes or no? But before moving ahead, let us write some more points about this electrostatic field. A positive charge will always experience force in the same direction as field. So a positive charge, if you put it in an electrostatic or electric field, it will experience force in the same direction as that of the field. But a negative charge will experience force in the opposite direction. Do we understand this?
Yes, sir.
Okay. Then we can also write the formula of electric field due to a point charge. Do you know the formula for electric field due to a point charge? Do you know the formula of electric field due to a point charge? If this is a point charge, let me say it is plus Q, and this is a point P, which is at a distance R. Can you tell me what will be the electric field at this point P created by this point charge? Every charge also creates its own electric field. So wherever there is an electric field, it must be created by some charge. Do we understand this? What
Yes,
is the formula of electric field due to this charge? Anyone knows it? Electric field का formula for a charge is K Q by R square. Will you remember it? Where K is your constant. It depends on the medium. 1 by 4 pi epsilon naught. Q by R square. This is the magnitude. Do we understand this?
yes, sir.
What is the direction? Direction of electric field is along the line joining charge Q with the point P. Do we understand this? Now, there could be two directions here. One direction will be this, or it could be in this direction. Which direction is the electric field? Is it in the pink direction? Remember, this is a positive charge. This is a positive charge. Is it in the pink direction or is it in the green direction? How will you find out whether it's the pink direction or the green direction? So remember, if the charge is positive, then the electric field will always go away. Positive charge, electric field is always going away from the charge. So if the charge is positive, your field will be going in this direction. If the charge is negative, then the field will be coming towards the charge. Do we understand this?
Yes, sir.
Note this down. I'll give you a few points and then we can call this class off. Special points about electric field intensity E1 or E. Have you noted this point?
Done, sir.
Again, it's a revision of what we have done. The first point is electric field intensity or electric field. It's what type of quantity? It's a vector quantity. Positive charge will always experience force in the same direction. Do we understand this?
Yes, sir.
The other way of saying this is, what is the direction of electric field created by a positive charge? A positive charge will create field in the away direction. The electric field created by a negative charge would be towards the charge. Do we understand this? Anyone understands this? Yes or no?
Yes, sir.
Dimensions and this, remember, these are very important dimensions because we normally forget these dimensions. So remember, the SI unit is Newton per Coulomb and the dimensional formula is MLT minus 3A minus 1, because they ask you many times the dimension of electric field, epsilon naught, mu naught. They are their favorite topics. Everyone understands this? Yes or no?
Yes, sir.
Again, the same point, electric force on a positive charge will be in the same direction. Electric force on a negative charge will be in the opposite direction. Everyone understands this? Yes or no? I've given it so many times that you would not remember it. Yes or no?
Yes, sir.
The next one is this. It obeys the superposition principle. It is a vector, my dear friend, so it will obey superposition principle. So if you have to find out the net electric field at any point, you add all of them vectorly. Do we understand this?
Yes, sir.
Shall I give you one small question to end of this class? This is the question, a very simple question. Calculate the electric field intensity, which would be just sufficient to balance the weight of the particle whose charge is minus 10 microcoulomb. Remember microcoulomb. 1 coulomb is a very big charge. Minus 10 microcoulomb and mass 10 milligrams. I want to balance that. How much electric field should I apply? For example, if the what? The charge is like here. Remember, the charge is minus 10 microcoulomb. Yes or no? The weight of this will be going like this, mg. Yes or no?
Yes, sir.
In which direction should I apply electric field? Should I apply electric field upward? Should I apply electric field downward, rightward, or leftward? I want to balance this charge. Should I apply electric field upward, downward, rightward, leftward, or where? I want to balance this charge. Yes?
Once.
Yes, sir.
Should I apply it downwards, upwards, leftward, or rightwards? Electric field, should it be applied in which direction?
Once.
It is a negative charge, remember, my dear friends. Yes? Upward, downward, leftward, rightward. In which direction should I apply electric field? Don't know? Well, then find it out and tell me in the next class when we come and meet, and tell me the answer. What will be the value of this electric field? Should it be upward? Should it be downward? Should it be leftward? Should it be rightward? I have told you this thing at least 10 times today in 10 different ways. I have to balance this point charge.
Right side, sir.
Right side, sir. Right side is wrong side here, sir. Because right side is not the right answer, sir. So think about it. Tell me the answer in the next class. I hope you have understood what we have done in today's class. We will be moving ahead and solving some more questions on electric field and covering this topic of electric field by the next class. Take care. Have a nice day. Bye-bye.